Dear students, welcome to my Whiteboard program. Today we will discuss science chapter your 12 sound. This is the first part. Let us see today what points we have to discuss. We will discuss today what is sound, then how does sound propagate, what are the compression and rarefaction, and how does sound need the material medium, how can you prove it. Sound waves are longitudinally wave, why it is called. Then characteristic of the sound, what are the various characteristics of the sound. Today we have to discuss these points. So come first, what is called sound? Generally we are very familiar with the word sound. When I am talking also, I am producing the sound. You can listen. So how this sound is produced? How you listen? So what is sound? Sound is a form of energy, because we know energy are different form. Light energy, sound energy, electrical energy, wind energy. Similarly, one of the form of energy is sound. And this sound move from one place to another place by wave motion. That wave motion is known as the mechanical wave. Why it is called mechanical wave? Because this needs the material medium. Without material medium, without any medium, sound cannot move. So those wave which move through the material medium are known as the transverse wave, and which are that is called the mechanical wave, and which do not need any material medium, they are called the electromagnetic wave. Light is also like a electromagnetic wave because it does not need any material medium. So from the sun it comes to earth through the vacuum also. But sound cannot move. If we will go to suppose moon or space, and if we will talk with each other, then nobody can listen because there is no material medium are there. So without material medium, sound cannot move. That's why it is called mechanical wave. So let us see. So sound is in the form of energy which propagate, means move in the medium with wave motion. It creates a sensation our ears so that we can perceive it. So sound is a form of energy which form the sensation, which create the sensation in our eye. So how do we perceive it? That is up to the interpretation of the brain. So brain perceive it so that we can listen the sound. That we have to discuss in next class. Let us next. How does sound propagate, or how does sound move? So when I speak, my sound is producing, and that sound is moving from here to you. That is how? Through the air. That's why I say sound is mechanical wave. It moves in the wave like through the air. Air is the material medium. So how does it move from my mouth to your ear? That is by when I put the sound, when I produce the sound. So this sound push the air particle in front of this, and this air particle push the next air particle, next air particle push the next air particle. In this way, the particle to particle disturbance are created, and this disturbance move from my place to your part, means your ear. In this way, the sound moves from one place to another place. So that is called the propagation. Movement of the sound is also known as the propagation of sound. This takes place through the material medium. That's why it is called the mechanical wave. So this is, for example, another. The sound when moves, it does not move the particle. Particle does not move. What move? The disturbance created by the sound moves. For example, in your class, in a bench, suppose there are 4 students you are sitting generally. But if the teacher say 7 students you accommodate in that bench, what will happen? You will sit very close to each other, and there will be tightness. And by chance, one will push you. Then what happens? The last student in the bench, it falls down. How? You did not push the last student. but the last student falls down because the disturbance you created by your adjacent student, that will move through the student to student, and finally last student will fall down. In this way, we also, when produce the sound, this sound push the particle, and particle disturbance move from particle to particle and move to the distances. In this way, sound is propagated. Now we will come. What are the compression and rarefaction? It is one characteristic. It is the characteristic of the sound. Sound when moves, it moves in the what is called your when sound moves, it moves in the longitudinal wave. So longitudinal wave we will discuss afterward. So compression and rarefaction means when the sound moves in air, it pushes or compresses to the front air particles and create a dense or high concentrated area or region called the compression. Suppose when I am producing sound is pushing the in front of the air particle, and the air particle are closing to each other, getting close to each other, making a high density area. That high density area is known as the compression. Again, when the sound is slow down, then they are coming back and there is a less pressure is developed. That less pressure is known as the rarefaction. I have shown through the figure. So when the particles becomes close, very close, their particles are very close, that is called the rarefaction. And when that is called the compression. Sorry, I have just altered. This is the compression and this is the rarefaction. This is compression. This is the rarefaction. This is the compression. So compression means the dense area where particles are very close to each other, pushing, compressing. That is compression. Again, it will form the rarefaction. You will see there is less density. Again, high density. Again, less density. In this way, the sound move from one place to another place by pushing and retracting. So that is called the compression and rarefaction. And rarefaction is the low density area. This is called when vibrating object moves away, it and creates a region of low pressure is called the rarefaction. So sound create the compression and rarefaction in the air and move from one place to another place. That is called the compression and rarefaction. Next point we will discuss. Explain with activity to show sound needs medium to propagate. I told you sound is mechanical wave. I told you sound is mechanical wave. What does it mean? Sound needs the material medium. Without medium, sound cannot move one place to another place, cannot propagate from one place to another place. That we have to also show with some activity. Let us come one activity that is called the bell jar experiment. So what is bell jar experiment? Go to the figure. This is a glass jar which is connected with the vacuum pump through it, and there is a electric bell is there. That is electric. When switch is given, the bell will start to ring. Electric bell. So this electric bell is connected to the switch here. So now there a person A and a person B are standing outside there near about. So when there is air, now it is closed. Every side it is closed. Your cork stopper is closed. Only connection is there. So whatever air in the jar, that is present only. Now the switch will be on. Now the bell will start to ring, and the ringing sound can be listened to A definitely. A can listen the ringing sound definitely. Now, so this why ringing sound? Because air is there. That is the material medium is there, and this vibration is coming to the air. From the air, it can pass to the outside. But when the vacuum pump is started, so all the air present in the jar are pumped out. And inside the jar, nothing is left, no air is left, means nothing is left. That is called the vacuum. And when the vacuum will be created, then you will see no sound will be listened neither A nor B. Because you see, A is listening first time, so sound was there, so laughing there. But B cannot listen afterward. So you see the figure how he is so sad, because cannot listen. So now A says, at that time air was there and I could listen, and B says, no, I cannot listen. That means no air is there. So without air, without medium, the sound cannot propagate, and so the B could not listen it. So from this experiment we can conclude that air is required, or any medium is required, material medium is required to propagate the sound from one place to another place. So this is about the experiment. That experiment name is bell jar experiment. Now let us come to the sound wave or longitudinal wave. Why I call sound wave is mechanical wave. That is what I have explained. Now I will say sound wave is longitudinal wave. Mechanical wave two types. That is longitudinal wave and transverse wave. Let us see the mechanical wave. Why it is called that is called the longitudinal wave. In sound wave, the particles in the medium oscillated to and fro about their mean position in the direction of the propagation of wave, but not perpendicular. Therefore, sound wave is called longitudinal wave, but not transverse wave as light wave. Let us see the demo. So, when the light moves, it moves like the compression, then rare friction, then compression, then rare friction. In this way the light moves. So it moves in the direction of the propagation. So it does not move the perpendicular up and down. It moves along the direction of the propagation. So that's why it is called the longitudinal wave. But let us see what is called the transverse wave. When anything will move like that, perpendicular, like that. Perpendicular, this is the direction of propagation, and this is the perpendicular wave. So in this way we call it is transverse wave. I have shown you what is transverse wave and what is longitudinal wave. This is longitudinal wave, that is called the sound wave, and this is called the transverse wave, that is perpendicular to this thing. So this is called the sound wave, which is known as the longitudinal wave. Let us come to the next point. Characteristics of the